Good morning to everyone. Myself, I am Suryanarayana, working as an assistant professor in PBR WITS Kavali. In manufacturing process subject, we are continuing with Unit 2, that is forging. Up to now, we discussed rolling and extrusion process. Today, in this class, we are going to discuss about forging. Forging is nothing but compression. Forging can be defined as a method of shaping heated metal by compression. The requirement can be finished by heating the metal under compression. The forging process evolved from the manual art of blacksmithing. We already know that in the manufacturing of axe formation, that is a smithy, blacksmithy processes. And next, the special tools that a blacksmith uses are various kinds of dies and fullers. Modern forging uses machine-driven impact hammers or presses, which deform the workpiece by controlled pressure. And next, the forging process is superior to casting. Why we are calling it as superior or higher or greater than casting? Why? Because in that the parts formed have denser microstructures, more defined grain patterns and less porosity, making such parts much stronger than casting. But coming to casting, we already discussed about casting defects. Coming to casting defects, we have gas porosity, that means blowholes, pinholes and open holes. These are the defects. Because due to that defects, the strength of the particular work material is decreases. That is the main reason for that. So for that reason, based on, we are calling it as it is superior than casting and usually have greater strength as compared with other methods of producing products. And next, operations. Forging operations. It is the oldest metalworking process. It requires first of all heating and then hammering. That means hammering in the sense of striking or blowing. The operations are drawing down or swagging, upsetting, coining. Coining is also known as closed die forging. Heading, open die forging, punching, hobbing, cogging, fullering and edging, and roll forging. First of all, skew forging. I am discussing about drawing down or swagging. It is nothing but the process of increasing the length and decreasing the cross-sectional area. That means area increases, increasing length and decreasing cross-sectional area of the metal is known as drawing. And next, upsetting. It is a purely reversible process of drawing down or swagging. In drawing down or swagging process, the area, cross-sectional area decreases and length increases. But coming to upsetting, in this, the cross-sectional area of the workpiece increased and length decreases. That is pure reversible process of drawing down process. Compressive forces are applied along the length axis of metal piece. And next, coining. Closed die forging. Closed die. Minting of coins where the slug is shaped in a completely closed cavity. The name itself, closed die. That means the cavity is completely closed by the dies. Is an example of closed die forging. To produce fine details of a coin, high pressures are required. Sometimes several operations that are needed, while lubricants are not used because if you can use, because they cannot prevent reproduction of fine die surface details. And next, heading. It is open die forging. Heading is an example of open die forging. It transforms a rod, usually of circular cross section, into a particular shape with larger cross sections. That is open die forging. The heads of bolts, screws, nails are the some examples of heading process. And next, punching. Punching means making of holes by using anvil. Hubbing. It is a piercing process where the die cavity produced is used for subsequent forming operation. Forming means changing the shape or size. Next, cogging. Cogging, also known as drawing out. Successive steps are carried out to reduce the thickness of a bar. That is the cogging process. Next, fullering and edging. Fullering, that means distribution of metal or material to certain regions, that is known as fullering process. And edging, that means distribution of the metal to the particular areas of edges, that is known as edging. Next, roll forging. We already know that what is a rolling. We are passing a material or stock in between two opposite rollers, but in this the compression is applied in between two rolls or two rollers. Examples are tapered shafts, tapered leaf springs, table knives, and numerous tools. Skew forging. Skew forging, that is the pure example for ball bearings. In making of ball bearings, we are using skew forging. Next, classification of forging. Coming to classification, those are categorized into open die forging and impression and closed die. Open die forging again classified into two types: hand forging and power forging. First of all, hand forging. In open die forging, I am showing that this one is the figure for explaining open die forging. In first figure, I am showing that in between two dies, I am placing one workpiece here, that is a rod. The workpiece does not covered by the dies. In second figure, I am applying some loads. After that, using the compression loads or compressive forces, that is reduced like a square, and after then due to frictional forces and barreling, that is changed like a cylindrical shape or circular shape. Next, open die forging is a hot forging. We already know that hot forging is nothing but above the recrystallization temperatures, hammering or pressing between flat or simple contour dies. In open die forging, the dies does not cover completely the workpiece. Next, metals are above recrystallization temperatures. I was already told you about that hot working process. And next, it must be reheated before forging can continue. Operations performed on open die process. Drawing out. Drawing out is the first process to reduce the cross-sectional area, increase the length. And upsetting. Upsetting is the pure reversible process of drawing. And next, upsetting, drawing and piercing process sometimes combined with forging over a mandrel to generate rough contour rings. Next, applications. Open die process can produce step shafts and solid shafts, hollow cylindrical shafts, ring-like parts, cylindrical shapes, wall thickness, internal outer diameter can be varied as needed. Contoured formal metal shells like pressure vessels, which may incorporate extruded nozzles. Classifications of open die forging. In that, we have to discuss about hand forging and power forging. First of all, I am discussing about hand forging. Hand forging, sometimes we call it as smithy or blacksmithing. Hand forging is the simplest form of forging, and it is the one of the methods by which metal was the first worked. First, the metal is heated like reddish formation, and then it is beaten into the shape on a metal anvil with sledges or hammers. Hand forging tools and equipments: anvil, swage block, blacksmith hammers, tongs, swages, fullers, and flatters. Anvil is a support. Anvil can be explained by using a diagram. Anvil is a supporting device which is capable of withstanding heavy blows rendered to the job. It is made up of a cast steel or wrought iron or mild steel provided with the hardened top. I am showing the figure of anvil here. This one is the anvil. The nose shape, that is known as beak or horn, that is used to bend the workpieces according to our requirements, and a hardy hole, that is used to change the squareable parts or square shaped cuttings, and cutting face, which is used to cut or trim the parts, and body, which is base which is fitted to the surface. Punching hole, that is used to making the holes according to our requirements, and next face is used to marking purpose or making holes, etc. Next, swage block, it is also a supporting and holding device. You can use it like for bending and making holes and changing the shape of particular material. In this, you can observe different shapes having different dimensions. Square having the dimensions from starting to final, and circles also from initial dia to final dias. These are used to change the particular diameters and areas of the workpieces. Swage block, it is also a supporting and holding device. Hammers, we already seen in daily life, hand hammers, sledge hammers. Hand hammer, that is used to, the weight of hand hammer is 1 to 1.5 kgs. We are using in daily life operations. And next, coming to sledge hammer, it is a 3 to 4 times of hand hammer. Heavy blows, whenever heavy blows are needed, in that time you are using sledge hammers. Again, sledge hammers are classified into cross pin, straight pin, and double faced type. These are the figures for normal and sledge hammer. Hand hammer is the ball pin hammer, and sledge hammers are cross pin, straight pin, and double faced. Next, tongs. Tongs are used to hold the workpieces. Those are made up of steels. Next, swages. These are also used in pairs. Those are top and bottom parts, used to reduce and finish the job to exact size and shapes. These are the swages. And next, fullers. These are used to necking down the workpiece. It spreads the metal and reduces the thickness of the particular workpiece. Fullers are made up of tool steel or made in pairs, up and down. These are the fullers. And next, flatters. These are used for finishing flat surfaces and are made with a perfect flat face. Flatters. And next, smith forging operations. Upsetting, we already know that it is a pure reversible process of drawing. And next, wagging, bending, welding. Welding means joining two similar or dissimilar metals. And punching, making holes or small openings, cutting out large holes in the material or metal. These are all expressions we discussed in previous slides. These are also operations of smith forging. And next, applications of hand forging: chains, hooks, shackles, and agriculture. Chains and hooks, these are Chains are the transmission systems. Hooks are used for holding the particular elements or particular parts. And next, shackles. Those are also used for logging purpose and agriculture equipment. Next, power forging. It is used to produce large number of identical forgings called presses. Thank you students. Thanks for watching.